with the
No.
Okay, we had a long weekend, so let's review. If I want to graph the system of inequalities, I just need to graph each inequality separately and look for the overlapping region, right?
Yes.
Which one are you looking at? I'll go through one of those too.
Okay.
Yeah, so you're looking for,
Because we wanted 3, 8, and 9.
okay,
Yeah, 3, 8, and 9.
okay, that's fine, we'll go through those. Let me go through one of these first. Yeah.
This isn't on our worksheet, right?
No, I mean, it's like one from your work.
Okay, cool.
Yeah.
No, it is on.
Okay, hey, listen, so now's when I need you guys to shut up and pay attention. If you're not doing that, you're doing the wrong thing. Right? I shouldn't have to wait, once I get up here, I shouldn't have to wait for that, right? Okay,
Are you recording?
I am recording, yes. Okay, so I need to just graph each of these inequalities separately and then look, the solution's gonna be the part that satisfies both. So that's gonna be the overlapping region, right? Okay, so let's do this first one. So talk to me about this. How am I going to, and we're kind of, I realize we're sort of in algebra mode here. We'll go into some applied ones and then we'll kind of look at how we apply this. But let's just make sure we're really clear with the algebra. How am I gonna deal with this first one? This guy. And there's more than one way to do this. How do I graph that inequality? Yeah, I could just put it in slope intercept. Right. And that's a pretty good bet. We could pick some points and try to connect and extend with 2 points, like with the intercepts or something. But let's just put it into slope intercept point. So what are the steps to get y by itself?
Move the x, divide by 2.
Okay, so I'm gonna move the x over to the right side. Everybody agree?
Yes.
So that one's gonna give me, step one's gonna be 3y is less than or equal to negative 7x plus 18. Put the x term first so it'll look like slope intercept form. Then, now what?
Divide by 3.
Okay, divide by 3. So if I divide everything by 3, I'm going to get y by itself. I divided by a positive, so there's no reason to flip the inequality. What am I going to get for my coefficient of x then? Okay, so negative 7/3 is my slope. 18 over 3 is 6. Okay. So now we got a boundary line that we can graph. Is the boundary line going to be dashed or solid here? How come? Okay, because I'm including, this is saying y is less than, which is the half plane, or equal to, which includes the boundary line, right? Okay? And so we've got a y-intercept of 6. So there's my first point. We got a slope triangle that's going to go where? Down 7, good. And right 3, good. So rise over run is negative 7. Oops, I think I messed that up, didn't I? I gotta go. Oops. There we go. 6. 1, 2, 3, 4, 5. There it is, right there. So there's my intercept. I'm gonna rise by negative 7. I'm gonna run by 3. And so there's my other point. It's a solid boundary line. So there it is. Am I shading above or below? Below. Okay, so everything down here is going to get shaded, right? Okay. Other one. What are the steps there?
Move the x, divide by
Okay, so I've got negative 3y is less than or equal to negative 2x plus 9. Divide by negative 3, okay, which means what? Ah, good. Okay, so I got a flip. Because I'm dividing by a negative, I've got to flip the inequality, so I'm going to get y is greater than or equal to negative 2/3 x.
minus 3.
Well, that should be positive, shouldn't it? Negative over negative is
Oh, yeah.
positive, and then positive over negative is negative. Everybody agree? Whoops.
Negative
Three.
3.
There you go. Now everybody agree?
Yeah.
Yeah, okay.
Yeah.
So we got a -3, there's our point. Our slope is positive 2/3. So we'll rise by 2, and we'll run by 3. And so these points overlap, don't they? That's the point of intersection. There's my boundary shading above or below? Above. Okay, and so then, what are we gonna get when we shade above? Can't remember if this, did it make purple? No, it didn't.
Yes.
So this really should be the part right here then. This is our, right? That's our intersection. We wanted below the blue and above the red, including both lines, right? So I guess really what I'd also like to maybe do here, because both of these boundary lines were solid, if the purple is the intersection, it'll be that window. Everybody see that? So I'm including the purple boundary lines, and just show it in purple, doesn't it? Anyway, you get the idea, right? Make sense?
Yeah.
Okay. All right, so what about some of these word problems? It sounds like before we do something like this, you wanted to maybe do, you want to look at number 3? Okay. So I'm not going to write this whole thing down. Maybe you guys have this in front of you, though. Everybody have number 3 in front of them
Yeah.
from the assignment.
Yeah.
Okay, it says in football, a kicker can score 1 point for the extra point on a touchdown or 3 points for a field goal. Logan is a kicker on his high school football team. The record number of points scored for a kicker in a single game is 24. Logan is hoping to beat this record in his next game. So it says write a linear inequality to represent this situation and then graph. Okay, so what are we going to do with this one? So what's like? Let's come up with some function that's going to represent the number of points that he's making in the game. Okay, good. So we're saying, and let's let P equal number of points maybe. So if we define P equals number of points, and you defined X as number of extra points, right?
Extra points from the touchdown.
Okay, so number of TDs / extra points, right? Is that what they want? They want it written in terms of, yeah, either way. They go together, right? Touchdowns and extra points. And then number of field goals, right? Make sense? So then, what's that going to give us for our function? P is equal to what in terms of X and Y? X, and these are worth 1 point apiece, right? So we get 1 times X plus 3 times Y. Everybody agree? Okay. So if he wants the number of points to be at least 24, what's that mean?
He's got a lot.
Just
Greater than.
right, he wants to beat his record, so he wants the number of points to be greater than 24, right? Yeah. And 24 is the record, right? So he needs to be bigger than that. Okay, so he's got to have X plus 3Y has to be greater than 24. There's inequality number 1. Okay? I usually only have one inequality. So if we graph this thing and they want us to graph it,
Okay.
X and Y. So what do we, we just have to graph that line. What are the intercepts? They're easy to find here. So if I set x equal to 0 and solve for y, what do I get?
8.
8. Okay, so let's get I want to go by 2's. So there's 8. So there's 1 point. And then what if I set y equal to 0 and solve?
24.
X equals 24, okay. So there's 24. Rather, and we could have also just put this in slope-intercept form, right? We'll do it the other way this time. So there's my 2 points. Do I want to connect, my boundary line should be dashed or solid? Dashed, okay? So I'm going to make a dashed line here then, that's going to connect these guys. And I want you to talk to me about, do you like that? I mean, it's not a very good line. I'm not asking for artistic praise here. Do you like, is the line that I've drawn, does that make sense?
Yeah.
Okay, is there anything I might want to do to that line to change it, given the context of this?
Make it like
Stop it at both intercepts.
Okay, I'm hearing lots of good, same things said about 27 different ways.
Like,
And that was that essentially what you're telling me is that we have to limit it to quadrant 1. Remember the quadrants in the XY plane?
Dude, I remember
Quadrant
that.
1, 2, 3, and 4. And we have to limit it to quadrant 1. How come?
because you can't make
have a
negative.
Yeah, we can't have a negative number of touchdowns or field goals, right? So we'd want to maybe take that algebraically, the boundary line goes forever, but contextually, within the context of the problem, we'd want to do this. We'd want to only include the part, pretty bad, you get the idea, between the 2 points, right? Now we want to ask, are we shading above or below, is all.
Above.
Okay, we're shading above, and the reason we're shading above is because if there's a couple, we could test the point for one thing, right? And let's just look at all our options here. If I test the point 0, 0, what would happen? So if I test 0, 0, I get 0 is greater than 24, which is false. And so I've got to shade away from my test point. There's one way to look at it, right? Another way to look at it, if I were to put this into slope-intercept form, what would I get? I'd end up with y is greater than negative 1/3 x plus, who cares, right?
Yeah.
My point is, I'm getting y is greater than some boundary line. And I don't even really need to know I just need to know y is greater than, honestly, I can even just say this, right? I can even just say y is greater than the line. If I put it in slope-intercept form, the direction of the inequality is going to be that way, right? And so we know we're shading above. Make sense? Okay, so this is, does it? Right? You see all I did there? I don't want to gloss over this. It's a pretty good trick. If I were going to put this, I've already got my boundary line, so I don't need to be specific and be very precise when I put this into slope-intercept form. I just need to know, am I going to get y is greater than mx plus b or y is less than mx plus b if I do it? Because I already have my 2 points that I connected. Agreed? Well, would you agree that if I do that, I'm going to subtract the x and divide by +3, which does not flip that sign? So I get y is greater than mx plus b, whatever that is. You don't care. You don't need it this time, right? And so we know that we're shading above. Right? Make sense? Okay, so then the last part of this says pick 2 random combinations that would give him the record.
200 field goals, 400 extra points.
Yeah, I could pick anything that's in this shaded region then, correct? So I could pick any point up here. So I could pick, obviously like one coordinate that's clearly in here would be, what if I picked something like 24 and 8? I mean, there's an example of a point that's above, that's in the shaded region. right?
Mhm.
Okay? So if I wanted to write this, one other thing then. If I wanted to write this as a system that gives me the right solution set, you told me that we had to restrict this to quadrant 1. In so many words, that's what you told me, correct?
Yeah.
Okay, how can I say that mathematically as a system of linear inequalities? Because it's really, would you agree, it's not really good enough to just say, this is our
Would you put it in
inequality, but then when you
absolute
graph it, just put it in quadrant 1. That's not very
value? Do
mathematical.
you have to put it in absolute value?
No, we don't have to. Have an idea? How would I say, how can I draw some boundary lines in here? Let's start with just the graphing part, and then let's work back towards the system. We only want the part that's in quadrant 1, right?
Say X is
Okay, so what's the boundary between quadrant 1 and the other boundaries? Well, one boundary is the y-axis. Everybody agree?
Yeah.
Okay, so here's one boundary that we need to include. It needs to be to the right of the y-axis. Well, wouldn't we just say that by saying my second inequality would be x is greater than or equal to 0? Everybody agree? And that's going to give us everything to the right of the green line. We already know that the blue inequality gives us everything above the blue boundary line. But then I also need everything that's, I need to include the x-axis as my other boundary so I don't keep going into quadrant 4, right? So then here's my other boundary line. What's that?
Y is greater than or equal to 0.
Okay, that's the line y equals 0, but we need to pick the y values above that boundary line, right? So the question doesn't ask for this, but I want you to see it this way. I really need a system of these 3 inequalities, don't I? To include everything that's going to be only the blue part of the graph, that graph. Okay, everybody good with that? Okay, and let me, I can really make this dramatic if I do this in Desmos. So there was our original inequality you came up with. So we've got the inequality x plus 3y is greater than 24.
Less
No, greater than,
greater than?
right?
Oh, right.
Okay. So there it is. I want that one to be blue, don't I? Got to match up with our graph. So there's blue. Okay. And then we had the inequality, if I keep going, we had x, you told me, was greater than or equal to 0. And that needs to be, that was green, right? Okay, bear with me. And then we had y is greater than or equal to 0. And that one was supposed to be, wasn't that red?
Yeah.
Okay, so where's that makes kind of an ugly brown, but where is our triple overlapping region? It's everything
So
right
it's-
in that kind of that. I don't
Oh,
know.
that is dramatic.
So it's
Yeah.
basically like
Right.
writing 2 equations.
Everybody see that?
Sure.
Okay, so let me get a picture of that just so we can put that in the notes.
That's a gross color.
It is kind of a gross color, but it illustrates the point. Oops. Okay, there it is for the notes. Make sense?
Yep.
Okay? All right, so then here's one that's gonna help you out with number 8 on your assignment.
On a different sheet.
Okay. Yep, yeah, this is very similar. So let's take a look at this one here. To raise money to attend Boy Scout camp, Alex is selling popcorn. Small bags of popcorn sell for $4 each and large bags sell for $6 each. He needs to earn at least $300, so there's one criterion, to attend camp. He will also earn a badge if he sells at least 60 bags of any combination, total of any combination, right? So he wants to do both of those things, right? He needs to earn at least $300 and he needs to sell at least 60 bags total, right? Okay, so what are we, let's kind of move through this systematically. So those all need to be closed. I want everybody with me. So now this is where I would say that people need almost the most practice is applications, right? Because this is where, I mean, you're really good at algebra, but making that transition into applying this to a situation, sometimes that's the toughest part. How does the math translate, right? We want to break this down into kind of a process that's going to work the same all the time whenever we're doing applications of any math situation. So what's the first thing we want to do? Define the variables, always define the variables. What are we going to call them? Small.
SL.
Okay, small bags and large bags. So, and we're looking at, what are we trying to track here? They're telling us the cost, so we're trying to track the number of each of them, right? So we could define, then we could say something like x equals, number of small bags, y equals number of large bags, right? Okay. So each one of these statements here should build an inequality then, because if we're going to come up with a system of inequalities, system of linear inequalities to represent the situation, there's two variables, we need to have two inequalities. So how about this first one? He needs to earn at least $300 to attend camp.
So 300 is less than or equal to?
Well, let's do the 300 last. Let's come up with the expression. What's the expression that determines the amount that he's earning?
4x plus 6y.
Okay, good. So 4x plus 6y. Everybody agree? That's telling us the amount of money he's earning from the sales. That has to be what? At least 300 means greater than or equal to. Okay. Does that make sense that at least means we includes equal to? If it said greater than or more than or something, then we wouldn't include the equal, right? So there's our first inequality. How about the second one? He needs to sell at least 60 bags.
X plus y needs to be greater than 60.
Okay, so x plus y needs to be greater than or equal to 60. There's my two inequalities, right?
So in that situation, the price doesn't count because you're just talking about how many, right?
Well, the price is given to us. It's $4 and $6
No,
per.
but in the second equation, you're not.
No, the price, right, and how do you know? Because it never does it ask anything about money in that second one. All we're doing is counting numbers in the second one,
Okay.
right? And that's, a lot of times, that's the sneaky equation or inequality that kind of sneaks by you, is they usually give you one where they give you a total amount of something. Where you're just adding up, and it happens quite a bit in these kinds of problems. So if we graph these things, the bottom one, if I put that into slope-intercept form, let's go ahead and just do this real quick. What's that going to look like? Y is greater than or equal to what?
Negative x plus 60.
Okay, negative x plus 60. How about this top one? We're going to get y is greater than or equal to, I'm going to have to subtract the 4x to the other side.
Negative 4
And divide by 6, so negative 4 over 6 reduces to negative 2/3 x
minus
plus 300 divided by 6 would be,
plus 50.
everybody agree?
Yeah.
Okay. So there's our two equations. Now that both of them are going to be solid boundary lines. So how about if we go by tens over here?
Yeah.
And so this one's going to be, we're going to go up by 50. So 1, 2, 3, 4, 5. Okay, so there's 50 on the y-axis. And our slope is negative 2/3. Well, do you get here that as long as the increments are the same on the x and y axes, even if I'm going by tens, explain this to me. Somebody articulate this to me, because this is kind of an important thing. If I know I'm going by tens here and by tens on this one, how can I just do this? How could I rise by -2 and run by +3 to get another point that I can use for my boundary?
Can't you just do it in the same way?
But if my slope is -2/3, how much did I really rise by here? 20, -20. And how much did I run by?
30.
Same ratio though, isn't it?
Yeah.
As long as we're moving by the same amounts, it doesn't really matter what the actual slope is. I can always just rise or run by equal amount of increments vertically and horizontally if the scales are the same on both. You get that? It's kind of a good little trick, right? Okay, so here's our boundary line. The boundary line mathematically is going to go forever, right? Do we want it to go forever? Not really, right? Because it doesn't make sense. If we're talking about the numbers of items that we're selling, you can't sell a negative number of things. And so we're really only going to take the line to go from there down to wherever it intersects the x-axis, right? So from there down to there, maybe. There's our boundary line. Shading above or below? Above, okay? So above. Oops. All right, you get the idea. So there's first solution. Next one. I've got a y-intercept up here at +60, and my slope is -1. So I could rise by -1 and run by 1. And there's another point. So I'm just going to go like, I don't know if I drew that right. You get the idea? There's my boundary line.
Yeah,
Shading above or below?
above.
Okay. So above.
That's really cool.
So where's the double, I mean, there's very little part that doesn't overlap.
Like the little bottom part.
There's just those tiny little wedges down there at the bottom that don't overlap, and so if I make it like purple, I guess, right, then it's gonna be, the overlapping region is just gonna look like this. Try to be strict. See what I'm saying? That's gonna be the part. Yeah, you get the idea. That would be my solution set in that whole region. Okay, and if I drew, maybe I'll do these in purple, so it look like this. Make sense? Okay. All right. What are two possible combinations? Well, right there and right there. There's a whole bunch of them you can choose. Any ordered pair corresponding to any place in the shaded region. Okay. Really, see if you can tell me this, and this is kind of above and beyond what they do on this worksheet, but what should the other equation, or other inequalities in that system be that we didn't include?
X is greater than 0.
Okay,
Or twice.
good. So we should also include we end up with these two, we should have x is greater than or equal to 0, and y is greater than or equal to 0. And what does that come from? The fact that the number of small bags has to be non-negative and the number of large bags has to be non-negative. Okay. And then that constrains us to that one region, right? Everybody see that? Okay? All right. Does that help? Katie, does that help? Okay. Yes. Helps. Make sense?
And then when we're at the two possible combinations, too, we just have to make
Sure. Okay. So why don't we, so the second test we're going to do is going to cover